is we need to now do the next part of the slides. And there's no practical after this actually, so what we'll do is, I like to do, is given, and chapter 3 is not big by the way at all. See, there are 2 parts of the one before it. Chapter 4 is about switches, and there's 2 parts, chapter 4 and 5 are both about switches. Chapter 5 is entirely about switch configuration, much like your chapter 2 has got config in it also. So what I'd like to do is do the theory of chapter 4 today. Okay? Not really labs in it also. Theory of chapter 4. And next week, chapter 5. Okay? It's the only week we've got 2 chapters. The 3 is so small, yeah? And 4 isn't bad either. 4 you'll see is quite nice.
Are we going to go for 4 now?
I'm going to do 4 now. I'm going to do 3, finish off 3, not much to do. Yeah? I'm going to do 4, which is mainly just some theory about switches, convergence. And next week's class will be chapter 5 largely, okay? And practical as well. So practical, that's really configuration matters the most. That's also in your skills test. And if it's too much to handle, you just need to tell me. You'll see now what I mean by this. So here we go. Start. Oh, recording. We're recording. Right. Okay, and duplicate screen. So hopefully, you know, that packet tracer activity you managed to do in class, which would be great. And this lab is something you can take away with you. 3.2.1.9 is the kind of configuration of basic RIP v2 on that topology. Yeah. So now route and table entries. There we go. Okay, so here we have, it's just showing you a routing table for R1. So R1 here, someone's done a show IP route on it. Here's an example of routing table entries. We're now learning about how we decipher what these are all about. So you can see a few things I'll pick up with you here. When you do a routing table, what you get is your gateway of last resort comes first, because it's got a pipe here. Then you've got your variously direct networks connected. S star, C, L, R. Those things will have, you know, certain meanings. You have your, when you've got sub networks, we'll show you how many subnets there are and the kind of masks being used. You also see which interface is also the one that's being referred to here. So it's quite useful information. And over time, this routing table gets really big. Okay, so that's a scenario there. Now, just to decipher some of this. So you can see, for example, I'll take a line of this out. 172.168.1.1/32 is directly connected on R1. Gigabit Ethernet 00. Let's look at that one. So 1132. Ooh, R1. 1.1 is right there. Okay. 172.162. Where did I go? That one there. 1.1 is right at that point there. Gigabit local connection, that black line there, it's local connection, that's locally connected switch there for you. And you can go around this whole like routing table and look at how these things are referred to in relationship to that R1 starting point. Okay, you should be able to take that apart and understand it. So here's like how that's done and the way you look at router entries. So router entry example, you've got C and an L. This green section here shows you how the route is sourced. Okay, the first thing, how was it learned by the router? That's your destination network, and now it's connected. And here's the interface, how the router connects to the destination network through which outgoing interface. One interface here is connecting to 2 destination networks from one point there. So when the interfaces are configured and activated, when you're doing the kind of config conf t on the router, and you're doing various, you know, kind of interface activations, you're doing the no shut and so on, that is an activating it, and then it's added then to the routing table. The information source, as I've described, is your route, destination, and interface. Okay. Other entries include things you can't see here are the S for static route. D is EI. It's not really intuitive at all, this, by the way. D is EIGRP. Okay, it's not what you expect, folks. Okay, so try and relate. C is connected network. Okay, relate C with connected, directly connected. Relate S with static. That's so fine. Relate O with OSPF and R with RIP. Okay, the other fiddly one, D is not directly connected. D is EIGRP. I don't know why the hell they chose D. No idea. Anyway, so this is the one that you to sort of those to pick out as being not your usual ones. To memorize this. Now, remote network entries, as you saw earlier on, are RIP, for example. We'll give you a remote network entry. So there's your root source through RIP. Destination network. I mentioned admin distance last week, which is like we saw. What does that mean, folks? Admin distance. What's another word for it? Trustworthiness. How close something is to you, and how far away it is to you. You know, it's like you might trust the closest friend you have, for example. It's like you should anyway, right? Etc. So you kind of work your way from that. And the metric is like an actual distance metric value there, which can increase very big. Next hop is your router, the way to the next place. You've got your timestamp when the route was learned and your interface there. There you go. The lower the metric, the better. Okay, on the metric value there. The rest is something which is very self-explanatory from this information. 35, okay, routing table entry. So what is a routing table? It is hierarchical structure and it helps do lookups quickly. So when you want to forward a packet somewhere, packet comes in, I go, right, oh, what's the IP address on the packet? Very quickly I can go here and use these network addresses, these ones here, to look up which way to go. Yeah, do I go down my direct route? Do I go down my via route or via this route? Those are the kind of options I have. So this hierarchy includes the concept now of ultimate route, level 1 parent, and level 2 child. Okay, so we have the first kind of concept of a parent and child route here. So what do these things mean? An ultimate route is a routing table entry that contains either a next hop IP address or an exit interface. Okay, so directly connected, dynamically learnt, these routes are ultimate routes. So here's some examples in orange here of ultimate routes. See that one there? So you got here C, directly connected gigabit Ethernet interface there, and these are other examples also of these routes that are ultimate. Level 1 route, and then we're going to parent and child. So level 1 routes can be some of the following things, okay? Network, supernet, or default. So this one here is a level 1 route, okay? That's because it's a default. See quad zeros, idea, default route, the one that you fall back on. This one here, okay, is also a similar route, 192.168.0.0 via this address and with a certain timer on a 0.0.0. This one, because it's got a /16 on it, okay, also has your mask intact too. So the different routes we have are, a network route is one that has a subnet mask equal to that of the class full mask. What are the class full masks, folks? Remember those? The different class masks that we have?
Class A, class B, class C.
Yeah, and what they mean, like, you know, your slash value. Do you know what the slash value?
0, 2.
So then those big numbers like 8, 16, 24, those big chunky ones, right? Those are where your kind of class 4 routes are, because they're the easy ones to sort of set up. So you got here, this is a /16 down here at the bottom, okay? So network route has a subnet mask equal to that of the class 4 mask. Supernet route has a mask less than the class 4 mask, for example, a summary address. The summarization address is, we've discussed not a little while ago, yeah? And a static route with the address quad 0 is the default route. That's your level 1 routes. Level 1 parent route, there we go, this parent route, see this like network address here, being a /24, okay, it's level 1 route. Off that route, okay, here you go, parent route. It is a level 1 route that has subnets to it. And the show IP route command will show you which ones they are. Anywhere it says variably subnetted, okay, in your route information, just go, whoa, zoom into this. Anywhere it has variably subnetted, and you've got 5 subnets and masks there, okay, that's your parent route. Okay, it's just saying it's a header for the subnets it then contains. Okay, so this kind of like masking and so on is showing you the 5 subnets that are involved with that. And here they are. Okay, your 5 subnets that come off this one address here, summarization. So the child root, that's going to be following on from this, should be quite logical. So that's the parent root concept. The child root, okay, this is called a level 2 child root, because now we're going to go one level down. So what you see here is, because that's level 1 root and that's the parent, off the parent is one of those subnets, okay? So quite simply, any of the things under that parent root are subnet roots, okay? So that one, to zoom in on this one, go over here. You can see that's your summary of a network. Here are your subnets within that net parent root. And if I go this way, you'll see how they're described. Ooh, a bit better mouse than this. Okay, there's your child roots are there. So parent root, there's your 5 subnet roots there, which are called level 2 child roots. Okay, all level 2 child roots are underneath level 1 parent roots. Okay, and it's recognized as defined as a subnet of a classful network address. Root lookup process. So how are the roots looked up? So what happens is, when the packet comes in, okay, we look at the best match for it. If it is a level 1 root, okay, then we move that route, we move that packet down that particular route. If the best match is the parent root, this level over here, okay, then the router then examines all the child roots and subnets. If there's a match for the level 2 child root, that is then used to forward the packet. Now, what happens if there's no level 2 child roots? The router then searches level 1 supernet, or obviously default route, okay? So default is where it falls back. If there is a match, that route is used. Now, if there are no matches at all in the routing table for anything, like if, for example, there's no default route set up, for example, it's like a closed network, then the packet is dropped. And there's a certain timer when that happens, and that then no longer is operational. 1, 2, oh, that's recording my video here. Okay. Right, so that makes sense, folks, so far. Not so bad. It's actually a bit easier than static route, to be honest, in a way. Okay, now the best route equals longest match. And this is how we do this. So what we do is we get the IP packet, wherever the packet is we want to move on. Let's say I'm reading the packet. It's like an envelope, like a post envelope. I get the kind of, like, you know, here it is. Oh, here's my kind of, like, you know, packet. And on the envelope it says it's going to Moorhan, right? And there's his address. And there's his, like, his county and his town and his postcode. So what I'll do is I kind of, in a way, what they do is in post offices is they sort of like divide up all the letters into certain boroughs, counties. Which van is it going to go on? And it goes on that van and it goes out the door, okay? Or the post office. So what this is a similar thing. We try and match the most, you know, match the bits up to the nearest thing. Here's an example. So if I zoom in on this, so you got here IP packet destination. That's what you've been given. You take all those things. Actually, you know, the actual definition says this: the most number of far left matching bits with the destination IP4 address of the packet, right? So the far left is what we'll do. The route with the greatest number of the same far left bits, or the longest match, is the preferred route, okay? So that's the definition. I'll go over here now. So here we have all the left. We're looking for the one that matches the most number from the left side of these. Now I go over here and I go, right, get up to here, and I go, oh, look, my route 1 matching, but not longest match. Next one along, yeah, is to here. Okay, that's your next one along there. And the next one along from that is this one. That's the longest match. That has the most similar, well, loads of zeros, right? That goes all the way onto this one. Yeah? So, what is it? Why is that the longest match to packet destination? Yeah? So, let's go back on. I've got these 3 routes in my routing table. Yeah? These are my 3 routes. And with this /12 obviously means, you know, we're going to count back the bits, right? How we are. This /26 route, all these routes in the table, this one has, although they're all the same, they're actually identical, aren't they, right? This one has the most, the longest matched packet destination from the left side. Let's pull this out a little bit. Oops. Let's take the, I think this is taken off this example here, by the way. Yeah? 1, 2, 3, 4. Let's go into it. /12, /18, /26 are the 3 you've got there. Find the same thing. I think it's a different example. Looks at it. this .10 address is the kind of the end of it. You know what? In terms of examples, I would say this is a bit misleading, only because they're exactly the same, right? This is why it's causing a bit of a problem here. Okay, but it's taking the one. This is the longest match here. Greatest number of equivalent far left bits for the longest match. They're all the same. They're all the same. This is a quandary. Admittedly, why wouldn't you take route 1? Yeah, I can see that being a reason why. I think it's because of this. Because it's /26, okay, it's the longest in terms of what's available left for hosts. That has that many hosts, right? Yeah, available there. And that has, they're all taken up on network portion. So in terms of the actual, this one's 18, let's count them up actually. 26 is there, 18 is that, and 12 is that. That's why they've highlighted it, you know. So what they're trying to say is the highest, you know, number of available hosts we take from the left onwards. That's all network anyway. From there to there, okay, yeah, means all that is available as a host. That's one available as host 2. If I want to match this packet to the nearest one here, okay, 1010, given that there's all these zeros here as well, I'm not going to be able to use that stuff because it's available for something else. It's /12. It's available for network. So is that. Yeah, but this one is only available up to that point. Okay, so what you're advised to do then is look at these masks. Okay, the higher the mask is, if it's like a number like this, you're looking for the one which is matching. Okay, this mask will go up to here, right? Yeah, that's the sort of breaking point. So take it from there and see which one of this mask goes from there. That's the longest match. This one only matches to there. That one only matches to there. It's 12. Yeah. So it's to do with the number of available hosts and bits available. These are not. These are already taken. That's what's left. Therefore, that one matches closest to that one there. Okay. I think what you probably would need to do is, if you're doing this in any exam situation, is make sure you write this out, this IP address fully. Okay. Just giving you alternative routes like these to choose from. You on paper simply work out, draw that line there, and work out which one's the nearest one to it. Okay. Based on the sub, because it's 26 of those, 18 them and 12 of those. Is that okay? That should be how you calculate your longest match point. So it's not a great example actually, but there you go. 42. Okay, routing table for IP version 6. That includes directly connected, static and dynamically learnt routes. And it says here all IP version 6 are level 1 ultimate routes. Okay, that's how it works for IP version 6. How you take apart an entry on a writing table, you do show IP version 6 route to display the table. They include the following things. So you've got here the root source again. C and L are local and learnt, so connected and learn local routes. You've got your address there of the network. You have your admin distance again, and your metric, okay? Lower is more trustworthy in all cases. Okay, then you have your interface at the bottom there, which is used to forward the packets there. That's how you take apart the IP version 6 table. 44 is remote entries. These are also learnt through different routing protocols. So you've got your root source. Was it learned through OSPF, like EIGRP or RIP or static? So you've got a D here. Again, your next hop is picked up, which is where you're going. Admin distance and metric. This is quite a big metric, you can see there, much larger one. Your next hop, and then your outgoing interface. Okay, and the process for looking up routes on IP version 6 is it examines level 1 network routes for the best match, and again, longest match is the best match. So you'll need to have a similar thing to how you did this to look up your best match, okay, on IP version 6. Just filling out the address in full and seeing how it matches up. This is not a very long chapter, okay? It's only finished, just finished here actually, yeah. And there's like no, from what I can see at the end of it here, there's no like practical activities other than what your interactive activities are in the chapter, okay? Yeah. And these ones are kind of all built in one sort of thing. And there's a lab that there's also a lab that goes with, which is very similar to Packet Tracer there. Okay. So I think, there's no practical here afterwards. Might I suggest, it's 8:30, that I show you chapter 4. It's largely theoretical, okay? And the practical parts of that, and the practical parts of chapter 5, which is very practical, are done next week. Is that cool? All right. That'll give us then chapter 5 next week. We can do the slides, and it's just dedicated to switches only. Is that right? C5. Sorry, stop it. Any questions on stuff so far? What's gone here? Is that all right? Everybody? Yeah?